So what we're going to do today is just basically looking at radian measure instead of looking at degrees now. We are going to look at radians, and you must know how to use radians or degrees with your class pad. I'm going to show you how to do it in a few minutes. All right? So we're going to talk about the definition of radian. We're going to talk about how we convert radian to degrees and back. And we'll look at angular velocity as well. All right. Now you really need to know how to define radian as a unit of angle measure. So you need to establish the relationship between radians and the circumference of a circle. So you need to think about using pi. All right? So you should convert fluently between radians and degrees and vice versa. Now, think about the sine, cosine, and tangent at an integer multiple of pi over 6 and pi over 4. We'll talk about why pi over 6 and pi over 4 is important. All right? You should be able to perform calculation using right angle and non-right angle trigonometry when the angle is given in radians. And then understand what angular velocity is or angular speed is. All right? Now, let's start off looking at how we could derive the radian. Back to your unit circle. Unit circle is when you have a circle with a radius of 1 unit. And you know that the circumference of this circle is therefore 2 pi times 1, which is 2 pi. Correct? Yeah? So now let's think about the arc on the circumference of the circle with the length of 1 unit. So this 1 unit now is just 1 unit over there. It's the arc on the circumference of the circle. So how many times do you think you can fit this arc length in the circumference of the circle? How many times? All right, let's have a look at the next bit. The radius, theta r. Now, notice that we now use r in the exam or in the test paper from now on. If you do not write degrees, we are going to assume that it is radian measure. All right? And I have seen, yeah, you must remember that I have, for me, if you make one mistake, that way, I will give you a follow-through mark. I remember many years ago, my daughter's friend actually made a mistake like that. The whole paper was considered 0. A test on a topic test on a trick. Not me, I will follow through, all right? But make sure that you have R or degrees. If you don't have R, which is what people don't normally write, we'll assume that it's R, all right? Radians, not degrees. You must have degrees. So a radian is the size of the angle subtended by an arc of a circle, which is the same length as the circle's radius. So that length itself is actually radius. The radius is the same length as arc length. All right? And that bit, that angle there is 1 radian. So in a sort of way, it's like an equilateral triangle, but that bit here is actually the arc of the circle instead of straight. All right? So that's how a radian is defined. Now, I am going to say that there are 2 pi radians in a circle. Prove it to you. All right? Let's have a look at the diagram there. All right? See how it's moving. That's pi radians. Watch again. We start off with, and then 2 pi there. Start off with that, that's a radian. That's a radius. 1. That's 1 radian. And then they move across, 2 radians, 3 radian, pi radian, and finally, the whole thing is 2 pi. All right? So therefore, our conclusion is that pi radian is 180 degrees. 2 pi radians is therefore 360 degrees. All right? So remember, pi radian is 180 degrees. 2 pi radians is 360 degrees. Now, can we therefore think about the relationship between degrees and radians? All right? Given that there are 360 degrees in a circle and 2 pi radians, how many degrees are there in 1 radian? Can you work that out? How many degrees are there in 1 radian? 1 radian. So you know that 360 degrees equals to 2 pi. Alright? So therefore, if you want 1 radian, alright, 1 radian is 2 pi radian divided 2 pi radian, correct? So therefore, 1 radian is actually 360 degrees. I've written the radian incorrectly. It should be like a degree. Divided by 2 pi. Alright? So 360 divided by 2 pi, that is approximately 57.2958 degrees, which is 57.30 degrees. Alright? Pi is still 2.14. Use your class pad. Alright? Now, given that there are 360 degrees in a circle and 2 pi radians, how many radians are there in 1 degree? Same thing. Oops. 360 degrees equals to 2 pi r. 2 pi radian, not r, not rad. What am I talking about? This is radian, 2 pi radians. So therefore, 360 degrees divided by 360 degrees equals to 2 pi r divided by 360, 2 pi, what am I doing? 2 pi r, 2 pi radians, 360. Alright? So, therefore, that equals to approximately 0.02 radian. Alright, approximately. So that's how you do it. 360 degrees divided by 360, that's 1 degree. So 1 radian is approximately 57.30 degrees, and 1 degree is approximately 0.02 radians. Yeah? Not 2 pi radians, not 2 pi r, okay? 2 pi radians. Sorry? Yeah, but you're converting between radians and degrees. It is 360 over 360, of course. So you want 1 degree, so it's 360 degrees divided by 360, that'll give you 1 degree. 2 pi r has to be divided by 360. Alright, or you can use pi, because pi radians is 180. Alright, now, you've got this. Can you actually convert the table for a commonly used angle? In particular, the most important one would be, I would say 30 and 45. So what would 90 degrees be? That should be pi over 2. Thank you. And 45 degrees will be 60 degrees? Yep. And 30 degrees? Alright, keep going. You can do the rest. I would, if you look at all the angles there, why did I highlight 30 degrees and 45 degrees? Why did I do that? Thank you, Jason. So with actually using those, you can make out all the others. For example, 120 degrees is 4 of them. Correct? 15 degrees is half of 30 degrees. 90 degrees is 2 of 45 degrees. 180 degrees is 4 of 45 degrees, and so on and so forth. Now check your answer. This is how I've got it. This answer.
Yeah, you know that 60 is.
Yep.
Times by 2.
All right. Can I move on? So make sure that you know pi over 6 and pi over 4. Those are the one based on 30 and 45 degrees. You could come up with quite a few of the others. So 30 plus 45 degrees, the other one you can think of is 75 degrees. So therefore, they are really useful, especially when it comes to the ratios. Now, can you convert the following angles from degrees to radians? Answer exactly to 2 decimal places. So you know that 180 degrees equals to pi radian. What is 20 degrees? All right. How do you do that? I think I got 0.3491 radian, approximately 0.35 radian. All right. I'm going to show you how to use ClassPad to do it. Do the others first before I show you how to use ClassPad. So either use 180 degrees equals to pi radian, or 360 degrees equals to 2 pi radians. All right. Hopefully I've got all my answers correct. Now, can you grab your ClassPad, please? I want to show you. Actually, we might not. We might do the next first before then we'll do the ClassPad together. Go to the next one first. Convert the following angles from radians to degrees. Answer to 2 decimal places. All right. You know that pi radian equals to 180 degrees. How could you actually use it? So we know that pi over 3 radian times, so 1 degree is actually pi radian over 180, right? So converting radian to radian to degree. And that would be 60. Right, pretty straightforward. And finally, that is about 87.096. All right, let's use your ClassPad. How do we change from degrees to radian and radian to degrees with your ClassPad? All right, grab your ClassPad, please. All right, grab your ClassPad. Go to main, everyone. Go to edit, clear all, please. And clear all variables. Now, when you use your ClassPad, this is the time that you should not use your scientific calculator at all. Here, tab again is GRA. Please do not use gradient. I've never actually ever used gradient in my life. I've only used radians and degrees. RAD or DEG. Don't have to use GRA at all. I've never used it, like I said. All right? Now, if I want to convert 20 degrees, what you need to do is go to keyboard. All right? Keyboard, this is degrees. This is radians. All right? Degrees and radian. So if you type in 20 degrees, all right? Now, make sure that this is radian. Change that to radian and tap execute. It will give you pi over 9. Or, if you like, go to decimal, tap again, 0.34. All right? So put that as degrees and make sure that you've got this in the radian mode. Now, to go from radian back to degrees, I'm going to keep this at degrees. And 1.52 radian. And tap execute. It gives you a degree. So this is how you could use your class pad to change from radians to degree and degrees to radian. Alright, are you all comfortable with that? So you must make sure that there could be a decimal or standard. See, if you type in standard, this will give you 1368 divided by 5 times pi. So there are two ways of doing it, decimal or in terms of standard. Make sure that you know how to do that. Everyone happy with it? Yeah? Yeah. Okay. Let's go back. All right. Now, given that exact values exist for sine, cos, and tan in degrees, the same exact values exist in radians. All right? So make sure that you know the two important angles, 30 and 45 degrees. Every critical angle with an exact values can be expressed in an integer multiple of 30 or 45 degrees. All this could be expressed as 30 and 45 degrees. So 30 is pi over 6 and pi over 4. All right? So you do have the unit circle diagram that I gave you. And if you like, again, make notes. I've given you one of these as well. So make notes using your unit circle. All right? So those are the two important angles, 30 and 45 degrees. Now, remember, when working with angle, change your calculator or calculators to radians. You can see that it's a lot easier using your class pad because you can just tap on it. If you use the scientific, you've got to go into the mode and change. It's a lot of trouble. And also with the scientific, you don't get your standard value. You don't get your pi. All right? Make sure that you use your class pad. All right. Now, can we work on some trick with radians, please? Instead of using degrees, can you calculate the values of x? So what would you do in this situation? What are you going to do with this situation? Use sine. So right angle triangle, use your ratio. So sine pi over 5 equals to x over 12.5. So therefore x equals to 12.5 times sine pi over 5. Now you can use your class pad and it should work out to be 7.347 meters, approximately 7.35 meters. All right? So use your class pad in the radian mode. Now, angle of inclination. Determine the angle of inclination in radians. That the line 3x minus 2y equals 6. So how do you do that? Can you remember what angle of inclination is?
The gradient.
Gradient. So what you need to do is rearrange this. Rearrange the equation. You know that 2y is therefore 3x minus 6, and y equals to 3x over 2 minus 3. Right? The angle of inclination, tan theta, is 3 over 2. So therefore, theta equals to, use your calculator. I'll actually write it down properly. Should be 0.9828 radians, or approximately 0.98 radians. Alright? Make sure that you get used to the habit of writing radians or degrees. Alright, let's go on to the next. Now, non-right angle triangle. You need to think about using the sine rule or the cos rule, correct? So can you determine the value of x, 2 decimal places, and exact value of y? So let's think about exact value of y first. So you know that this is an isosceles triangle, correct? Yeah. So, isosceles triangle, so y would be, what is the total? 180, which is? Pi, correct. Pi minus pi over 7 divided by 2. Yeah? Which is 7 pi over 7 minus pi over 7 times half is therefore 6 pi over 7 times half, which is 3 pi over 7. Alright? So therefore, you can give that is in the exact value. Alright? Radians instead of degrees. So now the next thing you need to look at, you could use sine rule. X over sine pi over 7 equals to 12 over sine y. Or this time, because it's exact value, 3 pi over 7. And I work out x to be about 5.34 centimeter. Remember your units. Oh, not centimeter, it's actually meter. Alright, example 6. Again, non-right angle triangle. How could you work out the value of x? Same thing, use sine rule. Sine, oops, hang on, let me rewrite that, it's 14 divided by sine x. (14 divided by sine x) equals to 16 over sine pi over 4. Alright, now, therefore, sine x equals to 14 over 16 times sine pi over 4. And if I work out, yeah, I think x is 0.67 radian. It's actually 0.667110.0358 radians. Alright, from class back. So I just make it into 2 decimal places, that's all. Generally 2 decimal places will be enough. Alright, use the same idea, example 8. Example 8 and example 9 is actually the same triangle. So you could work out what this angle is and then work out the area, which is half AB sine theta. Correct? Remember your area? Area equals half AB sine theta. Right? So, let me see what I've done. Okay. What I did was theta equals to pi minus pi over 4 r minus x. Now, because in the exam or test, that will be a follow through. So what I need you to do is make sure that the reason I showed you this is I want you to use this as x. rather than 0.67. Use that. You can use your calculator, pretty straightforward, and I work out the area equals to, this is actually 3 pi over 4 minus x. Alright, this is theta. So I work out the area to be approximately 111.22 units squared. That's about that. Using half AB sine theta. A is 14, B is 16, and sine theta is sine 3 pi over 4 minus x. Now I'm going to pause here for a minute. I would like you to think about how you could solve example 10, please. If you could work on example 10 for a couple of minutes, you can discuss with your friend. Alright? So the only thing that I want to alert you to, the angle of elevation is always measured from the horizontal. Alright? One is pi over 6 and one is pi over 3. So you should know that this is pi over 6r and this is pi over 3r. Alright? I'll let you work on that.
The angle of elevation from the positive x-axis?
No, it doesn't matter. It's just always from the horizontal, that's all. You measure from the horizontal. Angle of elevation is, there's no direction. Not what I may call it, not something like bearings, not something like what we are doing. Alright? It's always from the horizontal. That's it.
What is the difference to angle of inclination?
Yes, angle of inclination is always measured from x-axis. Alright? That is, yes, angle of inclination only applies in Cartesian plane where you've got a straight line. Cartesian x-axis 2 pi from x. So this is positive, that will be negative. Negative.
But angle of elevation is...
Yes, horizontal.
Yeah, that's what. Yeah, that's right.
From A to 4, and then you can use
For what? Why would you do that? Oh, I didn't get that. I didn't get that value. Like, just me try. It might be. I don't know.
I got 20.
Just remember, you cannot find h straight away. You've got to define one or two other measurements before you can do it. You've got all the information there you require. The angle of elevation, the two angle of elevations. You've got the hypotenuse for one of the triangle and the side of one of the triangle. They are both right angle triangles. I can tell you, if I give this to you in degrees, you straight away can see it. Alright, I'm going to reveal my... Are you ready for me to reveal?
1 second.
Okay, alright. I'll take my time. You take your time. 1 more minute. 2 decimal places. All right. Wow. I'll show you my answer. So I've done it by defining, oh, there shouldn't be x. There shouldn't be x. Shouldn't define 2 x's. So let's change that. That is, actually I'll leave that as x, but this one will be, no, actually I don't need that x. I don't know why I defined that x. This is not correct. Alright. Now if you use 17.67, it's not going to be correct, because you need to make sure that you use this number to calculate y. Although I wrote down y is approximately 10.21, I define x and y. You know x plus y equals to 18 meters. Alright? X plus y equals to 18 meters. So therefore, you could start working out x. You know this. You know the hypotenuse of this right angle. So cos pi over 6 is x over 9. Therefore, x equals 9 times cos pi over 6. And you've got this long number, but you can, when you answer the question, write down as 2 decimal places. When you use your calculator, use that. You can work out y is 18 minus that. Use your calculator. Alright? Once you've done that, when you substitute in here, using 10, pi over 3 equals to h on y, the y is this number here, 18 minus that, not 10.21. Fine for you to write it down, but use the number with lots of decimal places and work out your h, which is about 17.68 meters. And then only round it right at the end. Do your calculation with all your decimal places, round right at the end. Alright? Remember, especially with trigonometry questions, you always have to do that. Quite a few of you in the first semester exam did not do that. Alright, the last bit, I'm going to talk about angular velocity or angular speed. Now, when you talk about angular velocity, you're talking about something which is rotating. Alright, like a wheel rotating, or look at the fan. The fan is rotating. So each rotation is 2 pi. Alright, one revolution or one rotation is 2 pi radians. That is important for you to know. Alright, one revolution, because it goes around in one circle, is 360 degrees, or one rotation, that is 2 pi radians. It's 360 degrees. Alright, look at the fan, look at the car, the wheel rotating. Alright, so like a linear velocity is a change in displacement over time. Angular velocity is actually the change in angle over time. Instead of changing velocity, is changing angle. Now, we refer to angular speed if we don't think about the concept of direction. Well, have you all done velocity and speed in physics? Yes. So velocity has direction, speed does not have direction. Alright? Remember that. Velocity always has direction, speed doesn't have direction. Alright? So, now, what you need to think about is the unit is now revolution over time, such as revolution per minute or revolution per seconds. Alright? Or radians over time, radians over second, radians over degrees, and degrees over time, so on and so forth. Alright? So the time could be in degrees, could be in whatever. Seconds, could be in minutes, could be in seconds. Alright, last bit. Just converting the angular velocity from radians per second to revolution per minute. So, we start off with changing it to, this is radian per second. That equals to 6 pi over 5 times 60 radian per minute. Correct? So that is per seconds. To make it to minutes, you're going to multiply it by 60. Correct? Yeah? So 1 second is 60 seconds is times 60. And therefore, you can actually change that to 12, which is 12 times 6 pi radian per minute. Now, to change from radian per minute, this is 72 pi over 2 pi. That will be revolution. 1 revolution is 2 pi per minute. So therefore, that is 36 revolution per minute. All right? Now, to change from 2 revolution per minute to radian per second. So 2 revolution per minute. 2 revolution is 4 pi. All right? 4 pi radian per minute. So to change from 4 pi radian per minute, you need to change it to, you need to divide it by 60 per seconds. So 4 pi divided by 60 radian per second, which is 0.21 radian per second. All right? So you need to do it step by step, change it to minute first, and then change from radian to revolution. And or revolution first to radian, and then change it to minutes or second. All right? So that's all I have for you today. And just quickly reflecting on your learning, you should know how to define radians as a unit of angle measurements. You should be able to establish the relationship between radians and the circumference of a circle, and therefore it is pi. And think about how you convert from radians and degrees. Sine, cos, and tangent, and integral multiple of pi over 6 and pi over 4. We'll do a little bit more next week of that. And then do your trig calculation based on radians. And finally, understand what angular velocity or angular speed is.